Good afternoon, everyone, and thanks for joining this talk. I'm Magali David-Cru, I'm Solution Architect at Red Hat, and I'm pleased today to welcome one of our Swiss Romand customers, TPG, Transport Public Genevois, that will explain us how they regain control of their delivery process with OpenShift. If you have any question, please put it in the chat. They will be answered at the end of the talk. So now, please let me introduce you Mr. Charles Gauchon and Mr. Pascal Romanens from TPG.
Hello, everybody. Basically, today we are going to share our experience on OpenShift, and our topic is to regain control of your delivery process with OpenShift. So, who we are? So, as I said, my name is Charles Gauchon. I'm the head of IT infrastructure and operations at TPG. Basically, I'm focused on SLA and IT process optimization.
And hello, everyone. My name is Pascal Romanens. I'm an IT architect at Public Transportation of Geneva. I'm the main contributor for the implementation of OpenShift and the adoption of the DevOps practices at TPG. Don't hesitate if you have further questions to get in touch with me on LinkedIn. Let me give the speech to Charles, who will give us some context about what we do at TPG.
So, what we do. So, TPG stands for Transport Public Genevois. So, basically, our mission is to transport people. We transport 600,000 passengers per day. We have more or less 50% of electric vehicles, different types of vehicles, trams, buses, trolley buses. And we have one line with autonomous vehicle. Concerning the context of the IT operations team, so there are 13 IT engineers with different jobs, and we are running 700 VMs on a very classic vSphere configuration. We have 580 Windows servers, 120 Linux servers, and what is particular in our environment is that we are a public sector company, so we have to deal with public tenders, and this leads to have a heterogeneous IT landscape. And we have a lot of projects still with the COVID crisis, and we have also a lot of IT services to support, and a lot of vendors with different technologies and procedures.
Okay, and Charles, can you give us more details about our Linux environment at TPG?
Yeah, we have to mention the Linux environment because the Linux footprint grew up from 20 to 120 VMs during the last 3 years. So it's quite impressive. And the trend is still a fast-paced growing Linux market share versus Microsoft. And we have to support several Linux distributions, Debian, Red Hat, and SUSE. And what we can say is that the TPG Linux environment is much less mature than the Microsoft one. And we have one Linux dedicated engineer only from August 2020. So we are going to present you two different converging points of view, the point of view of the IT operations and the delivery process point of view.
And today, Charles, as the head of infrastructure, what are the current pain points you are trying to address?
Oh, well, nothing really special or very original. I think that we have the same issues we are sharing the same issues as many other companies. So we have more and more audits and more certifications. And so we have to work much more on security patching, OS lifecycle management. And as we said, we have a lack of skills on Linux. Especially, we feel this lack of skills in the phase of provisioning and configuration, because as we said, we have a lot of projects. And this is a Microsoft environment. And so our big challenge is to improve the Linux skills in an effective manner. So to do this, we have set a list of objectives. And the main one and the most important one is the first one. We wanted to reduce the Linux OS footprint, to improve standardization, and by replacing the VM with containers. So I said precisely Linux OS footprint, not Linux overall footprint. And this in order to simplify patching and lifecycle management, to improve security, to reduce maintenance windows impact from the IT ops point of view, but also from the customer perspective, to reduce skills dependencies in all the IT operations, to improve knowledge sharing, and to invest more in automation technologies. Basically, we are talking about DevOps here, and to focus our training efforts on one main hosting technology after VMware. So VMware has been introduced more than 10 years ago. Now we are going to the next step. So as an IT manager, I have the same view as many other IT manager, is the one-click upgrade. So Pascal, can you tell me, this is possible?
Well, I certainly hope I can answer your question, but before I do that, let me give everyone a quick summary of where we come from. So what we had a few months or a few years before is summed up in this slide. So as you see, we had a lot of different stacks ranging from Node.js, Java, Angular, PHP, .NET, etc., running on IIS, JBoss, Tomcat, Apache. And our delivery process was not standardized. As you can see in the middle square, we had no central delivery. So each application, each vendor had its own channel. It could be FTP, USB files, or email, you name it. So nothing standard. And regarding deployment, it came down to manual operations. So for most of our application, we had our IT colleagues who would perform shell scripts, PowerShell scripts, deploying zip files, etc., starting services, stopping them, and so on. And regarding the fallback, since nothing was standardized, well, we depended on our VMware infrastructure, and we prayed that the snapshot we took before each migration would be operational in case we had to fall back. So the disadvantage we had is that we had no version control. So no easy way to roll back if something was not going on when we are going to deployment in production. The same processes were repeated again and again for each deployment and manually. So it was time-consuming, error-prone, costly, and what I can say is often one application was deployed by the same people. I mean, the knowledge of deployment was held by the same group of people. So if one of our colleagues was off, then we had a problem. So this number of stacks, which was obviously too many, the fact that we had no integration team at TPG, well, it led to a lack of skills. So we didn't have the appropriate skill to maintain and deploy all these different stacks. So we had to delegate these activities to some of our suppliers. And to do that, we had to grant them with privileged accounts on our infrastructure, and this led us to a total loss of control of our delivery process. So today, it's time to regain control, and I will try to answer Charles' dream and tell you how we did it in 4 steps.
Okay, so how can we do this?
So the first step is the most obvious one, and it tries to address the fact that we had no standardized channel for delivery. So we regain control of our source code. The thing we did was to implement a Git repository. We had none before, so the source code was held by our suppliers. And as you saw on the previous slide, it was delivered through email, USB, or whatever. So we implemented Git, and now everything is delivered in our Git repository. And if it's not in Git today, then it doesn't get deployed. That's it. And by implementing Git, we also used every feature that it provides to support our delivery lifecycle. So we define a branching model that supports our different environment and the process for shifting application from development to production. We use version tagging for labeling the different version and be able to roll back if needed. And we use the pull request and request reviews of Git to move toward production. The second step is the fact that we regain control of our runtimes. So as we had many runtimes, we had different version of, well, we could have different type of runtime and then different version of runtime. We could have Java 8, Java 7, Java 11, whatever, not 10, 12, and sometimes different version for the same application in different environments. So the first thing we did, and it's very important to me, is that we took responsibility to provide our runtimes to our suppliers. So it's clearly, if you want to regain control, it is your responsibility to create and shape these runtimes and provide them to your suppliers, so they are able to build application on top of runtimes that you manage. So technically, what we did is we created a set of base container images, and by base container images, I mean we have OS containers, we have runtime containers, builders, and tools. And to control the versioning, what we decided to do is follow the editor versioning. So today we only provide long-term support versions. So I was mentioning Java earlier. So today we only support Java 8 and Java 11. And for Node, it's Node 10 and 12 today, and soon it will be Node 14. So we are sure that we took control of the runtime and the version of the runtime we provide. So after that, what we did is tune this runtime according to our needs and then infrastructure. Of course, your supplier will develop in its own environment, and when it will deploy to your environment, then it will not be working. And of course, someone will say, "I don't understand. It works on my machine." Well, the point is that it's not important if it works on his machine. The main thing is that it needs to run on your infrastructure. So what we did, we tuned our images. So, for instance, we embedded our own SSL certificates. We patched the configuration of our web proxies, and also we made sure that the runtime don't run as privileged user, but with just a normal user. And last but not least, we took control of the patching of this runtime. Since we own this runtime, we are able to patch them the way we want. So today, most of the runtime are patched daily, and some are patched on a more long-term basis. And the final point is that today, to enforce this policy on our runtimes, we forbid the usage of public registries like Docker Hub. I mean, I love Docker Hub. There are a lot of great content on Docker Hub, but the thing is that you can't claim that you have control of your runtimes if you don't know where they come from. So if you don't forbid the usage of public registry, what prevents a supplier or someone who make a mistake to change the configuration of your runtime and have something running from you don't know where on your infrastructure?
Okay, so basically here we are talking about standardization rules, but did we cover also security?
Yes, what we did is that we covered two use cases with Red Hat Quay registry. So if we forbid the usage of the Docker Hub, we need to implement our own registry to store our own images, and that's where Red Hat Quay comes into play. And Red Hat Quay also covers the security aspect. I will go into details for both these aspects. So today, when we build our image, they are pushed to our internal Quay registry, and this internal Quay registry is available to our suppliers. It is publicly available. If they have a contract with TPG, then they can have access to our Quay registry, and where they can access all our public images. And it's important to note that we have public, we also have private images, and we use the role-based access control inside Quay to segregate private images from public ones, to segregate images of a supplier from images of another supplier. And then in terms of security, one key feature of Quay is that it scans all the images that are pushed to the registry. So it will scan our container image and let us know when it identifies some CVEs. This feature integrates quite well with OpenShift, and it lets us know in our OpenShift cluster if we have vulnerabilities currently running. So let me give you a few examples with the following screen. Here is a screen of our public registry on Quay. You can see that we have images for Node, Alpine, Tomcat, OpenJDK. So this is the public registry I was mentioning. All the image in the TPG images factory are public and available to our supplier. And this next screen will illustrate the security scanning of Quay. So the example here is with our TPG-Python image. You can see that we have two tags, one running on Debian and one running on Alpine. And the tag on Alpine passed the security scan, and the one on Debian does not. Well, actually it does, but it quite just identify 11 low security issue. The difference is that Alpine is much smaller than Debian. It embeds less packages, so it embeds less vulnerabilities. On the bottom right screen, you can see that we have detail of the TPG Python Debian image, and there you have a list of packages and version and the CVE that Quay identified. So you're able to know precisely the vulnerability of your images. And this next screen will show you the integration between Quay and OpenShift. So those are screenshots from our OpenShift cluster. On the dashboard, this is the top left image. You can see that you have a number of vulnerabilities. So it aggregates all the pods that are running in your OpenShift cluster, and it will tell you how many vulnerabilities you have for these running pods. And the screen on the bottom right is an extract from one of our projects, the SDS Prod project, where we have several pods running, and you can see that we have a list of manifest vulnerabilities, and you know what pods are affected, and you can click on them and see the detail of the CVE. Here you can see that most of the vulnerabilities affect the TPG MariaDB image. It's because it's based on Debian also.
Okay, so what's important to understand in the TPG context is that there are no developers in the IT department. They are all coming from external suppliers. So in this context, how can we let our partners interact with our platform?
Yes, that's right. We don't have developer at TPG. So it is important for our supplier to be able to access our environment during the development and testing phase. So while we regain control of our environment, it was important that we define a governance that could grant our suppliers with the privilege they need. So OpenShift implements a large number of privileges that you can use and fine-tune the role precisely the way you want. Our approach is quite simple. Basically, the projects in OpenShift can only be created, edited, or destroyed by cluster admins, and cluster admins are TPG staff only. So when we create projects, we enforce resource quotas and egress IPs at the project level, and this cannot be changed or altered by the supplier. So what we create when we create a project is we create a sandbox where the supplier will be able to implement his application. So we create one project per application and environment. So we can have application A in development, staging, and production. Then we grant two simple roles, the edit or view role, and they are granted on a per group, per environment basis. That means that someone who has the edit role in a development environment for application A might not have the edit role in the same application, but in the staging environment. And this role-based access control is synchronized with our Active Directory, where we manage all the groups and organizational units. So this is an example of our infrastructure as code Git repository for OpenShift. In this repository, we define all the projects, all the application projects that runs on OpenShift. Here you can see that we have a project. They are separated by providers, and then we have B2B projects. And what I highlighted here is the development environment for this project. So you can see on the right part that we have an AD group tag, egress IP value, and then we have different resource values. So the AD group will be used for synchronization between the project airbag and the Active Directory. The egress IP will fix the IP from where the request of this project will be authored, and then we enforce CPU and memory limits to isolate the environment. So it's important to note that this Git repository is only accessible to TPG staff. So as soon as something is modified, it is automatically applied to OpenShift. Here you can see the same illustration, but from an OpenShift perspective, we have the same project, the B2B dev project. You can see that we have the labels for the environment and the AD group that are here, the resource quotas on the bottom, and on the right, the egress IP. Here, the same project, but from the role-based access control perspective, you see that we have the two roles binding, the edit and view one, and they are related to Active Directory group, the OpenShift SDS B2B dev, RW or RO. And if I go into the Active Directory, then I will see that this group are defined here. And then we manage the membership of the group in our Active Directory. What we did is quite simple. Read-only is the view mode. It gives you access to the project in read-only. You can access the topology, the different objects in view mode. You can access the log, which can be very interesting, and the monitoring matrix. In RW edit mode, then you have, of course, all of the above, and you can also log into the pod if you want to troubleshoot something at the container level. And you can also edit the project object like deployment, replicas, service, or route.
Okay, so what about the deployment process?
So that's the final phase, the final step of how we regain control. We define an infrastructure and how we deploy to the. It was important to define also how we deploy to this infrastructure. As I mentioned earlier, often we had one person who had the knowledge to deploy one application, so we had to externalize this knowledge. So that's why we implemented CI/CD pipelines. So we have CI/CD that automates delivery upon code changes, and we have also industrialized the deployment, so anyone can be able to deploy an application by the simple push of a button. So with this final sentence, I hope, Charles, that I partly or completely replied to your original question.
Yeah, my dream came true. So we have the one-click deployment process. Sorry. So from the beginning of our OpenShift journey, which began in 2019, we now have more or less 20 applications running in production. So this is a good news, but we still have a long way because we have many legacy applications to onboard. So there is still some work to do. What we can say today is that the adoption of OpenShift has set the first step of the TPG DevOps era with an IT transformation process. So we can see legacy sysadmins that are evolving to a DevOps automation engineer role, which is much more interesting. Git has become the key point of our sharing mindset. And now we think automation first for all our IT operations, not only related to OpenShift. And we have reduced our time to market, and we have much more transparent operations.
And the final, last but not least impression.
Yeah, this is important. We have improved the pleasure to work.
So thanks a lot, everyone, for listening to our talk. It was a pleasure to share our experience with OpenShift with you.
Thank you.
Thank you, Pascal, for sharing your experience today with the OpenShift community. So now let's answer to the question.